Children, we had already completed what is rest and what is motion. Today I have a presentation on the graphical proof of the three equations of motion. So this is graphical proof of equations of motion. So before starting the graphical proof of equations of motion, children, you all should know the terms related to these equations of motion. So the first term is our u. U is the initial velocity. Then is v. V is the final velocity. S is the displacement. A is the acceleration. And T is the time taken. So these are the terms related to equations of motion. Now let us come to what are the three equations of motion. The three equations of motion are, the first equation is v is equal to u plus at. The second equation is s is equal to ut plus half at square. And the third equation is v square is equal to u square plus 2as, where the symbols have its as usual meaning, that is u is the initial velocity, v is the final velocity, s is the distance covered in time t, a is the acceleration, and t is the time taken. Now we will prove one by one equation. So the first equation is v is equal to u plus at. So before starting the proof, the graphical proof, we have to draw a velocity time graph, where in the y-axis we have to take the velocity and the x-axis we have to take the time. Secondly, the object will start its motion from initial velocity u. The initial velocity is not 0. As we all can see, OA is equal to u. That is, the object has started its motion from an initial velocity u, and it has reached the final velocity, that is v, at the point B in time t. So in time t, the object has covered a distance. So we have to first, in the first equation of motion, we have to prove that v is equal to u plus at. So from the graph, OA is equal to u, then BC is equal to v. Similarly, OC is equal to t, AD is also equal to t, BE is also equal to t. Okay children, so suppose BC is equal to v and DC is equal to u, then the value of BD will be equal to v minus u. So now we all can put these values to prove the first equation of motion. So first is, as we know, the slope of the graph gives us the acceleration. So here the slope of the graph AB is equal to the perpendicular divided by the base BD divided by AD. As we know, the value of BD is v minus u and AD is t. So we can put the values to get the equation. So BC is equal to BD plus DC, which is also equal to BD plus DC is equal to OA. So that is, BC is v is equal to BD plus u. Again, A is change in velocity by time taken. So the change in velocity is BD by AD, or we can say that is BD by OC or BD by T. So as BD is equal to AT, so V is equal to U plus AT. And this first equation of motion is also known as equation for velocity time relation. Similarly, we can prove the second equation of motion from the same graph. But in the first equation, we had taken acceleration as a slope of the graph AB. But in the second equation, we have to find out the displacement, which will be the area under the graph AB. So from this graph, the area under the graph AB is a trapezium. So the distance traveled by the object is given by S is equal to area of trapezium OABC. That is equal to area of rectangle OADC plus area of triangle, you can say ADB or ABT. So area of rectangle, this will be equal to breadth into length or length into breadth, that is OA into OC. It will be U into T. Similarly, area of this triangle will be half into base into height, which is half into AD into BD. So AD, the value of AD is T and the value of BD is V minus U. So putting all these values, we will get S is equal to UT plus half T into AT, or S is equal to UT plus half AT square. And this equation is also known as equation for position-time relation. Similarly, we can prove the third equation of motion also. So the third equation of motion is B square is equal to U square plus 2AS. The symbols have their as usual meaning. So the same graph, we have to take the same velocity time graph. Here in the time graph, in the x-axis we have to take the time, and in the y-axis we have to take the velocity. So same, OA is U, BC is V, then AD and OC, that is T. So here also we have to find out S, displacement, that will be equal to the area under the graph AB. So distance traveled is equal to S is equal to area of trapezium OABC. Children, in the second equation of motion, we have splitted this trapezium into two parts. One was your rectangle and another was your this triangle. But here we have to put directly the formula of area of trapezium, that is sum of parallel sides into height divided by 2, which is parallel sides we can say OA and BC or CB, divided by 2 into height is our OC or AD, we can take OC. So this OA is U, CB or BC is B, this is V. So U plus V into OC is T. So we can take here T divided by 2. Or we can get from here T is equal to, S is equal to U plus V into T by 2. Again, from the first equation of motion, we know that V is equal to U plus AT. From there, we can get T is equal to V minus U divided by A. And putting this value of T in equation for S, we will get S is equal to U plus V into V minus U divided by 2A. Or solving this, we will get V square is equal to U square plus 2AS. And this equation is also known as our position velocity relation. So in this way, we can prove the three equations of motion. The first equation is B is equal to U plus AT. The second equation is S is equal to UT plus half AT square. And the third equation is V square is equal to U square plus 2AS. Thank you.